And we are rolling. Good night to be doing some of this. We're going to be having a little discussion. Welcome to JEHC. And we're going to be having a lengthy discussion on independent front suspension, design, etc., etc. I've got a outline I put together. This is 13 pages. Not going to get through it tonight. It's probably going to take multiple of these 2-3 hour sessions, etc. So probably 10 hours and change of information. So we're going to do a lot of defining of things, bits, and things like that first. First and foremost, I got to get rid of these glasses. That glare is brutal. God damn it. Oh, that's just partially blind from welding and all that good stuff for so many years. But anyways, so my name is Jason Elvis Hurd, and hence JEHC cast, whatever you want to call it, Jason Elvis Hurd cast. But I am co-founder of Tekkconsulting, and so we are a design development firm, full disclosure for all this type of bullshit, in multiple assets of the automotive industry. Specialize in chassis suspension design. We also do body design and things like that. So kind of see some of the services, large format 3D printing, and we can dabble. I'm going to hint at some of that stuff too in this discussion. So we'll drop some of those bits as well on the large format printers that we've been developing in-house. Cool. And I also own, DIY Off-Road. And DIY Off-Road is a digital asset marketplace for designers like myself, etc., to sell our digital assets to anyone that wants to cut shit out and build it themselves. So DIY Off-Road is the perfect place to acquire everything from like a raised truck chassis on down for tons of different things. We have designs on a lot of stuff. We're always adding stuff, and we're about to launch DIY muscle car. I know if you follow us on Instagram, etc., I've been saying that for a while, but we've just been slammed. So it's been difficult to get DIY muscle car going, and I don't want to put it up without like any cool or decent product on there. So we're getting this ball rolling. So tonight, discussion. Front design of independent front suspensions. We're going to break that up into two sections. We're going to break that up into long travel stuff, and we're going to break that up into center mount stuff. So when I say long travel, what I mean is stuff that goes on stock type vehicles. So that's going to be your Chevy Silverados, your Ford F-150s, your motherfucking Rangers, your Ford Raptors, Silverados, and it's going to be limited because, see, here's a perfect example. This is Nate, Blitzkrieg, BMS Off-Road. This goes on to an 0718 GM four-wheel drive kit. These are bolting to a stock chassis. So for obvious reasons, you have to deal with all the crap that the stock chassis has when you're designing it and making sure, it doesn't work like shit. So it does create some frustrations and headaches doing so. So when I say long travel kits or LT, this is what I'm referring to. So it's not the same as center mount type stuff, which center mount type stuff is completely different. So let's go to stage 2 bulkheads. So center mount stuff is going to be a center mount. It is, designed with its own chassis, so to speak, where we have our own bulkhead. The arms are mounted towards the center, hence center mount. So we're creating all of the pivots, and we are creating all of the geometry. This allows us to gain a lot more travel, allows us to control the travel appropriately, and have some other cool stuff. Better shock ratios, bigger shocks, better steering, a lot of things over a long travel-based setup. So to be crystal clear, there is no real good equivalency between a long travel truck and a center mount truck. And most of what we're going to be discussing this evening with IFS suspension design is going to pertain to long travel trucks and center mount trucks. I feel like, but there's a lot of stuff that does cross over into buggies, and we'll touch on some of that. There's a lot of stuff that does cross over into UTVs, and I will touch on some of that too. But I feel like, they need their own sort of discussions outside of what this, sort of core truck-based stuff is. And we'll get to that too. So just bear with me if you're a buggy dork and you're like, who the fuck? It's all just truck shit. Or if you're a UTV guy and you're like, I don't understand. All my shit looks way fucking different. And it does for the most part. And full disclosure, I do have a UTV, so I am one of those guys. And I do design a lot of UTV stuff. It is keeps our firm very busy, to say the least. So with that said, here's a list of the terms that we need to define before we go through the rest of this discussion and the rest of these episodes. So this is, I went through what the center mount and long travel stuff is. We're going to define, the uprights, the lower arms, upper arm, spindles, wheel mount surface, hub mount surface, track width, wheelbase, camber, caster, inconsistent, inclination, scrub, Ackerman, CPTC, bulkhead rake, travel, usable, metal, compression, ride, extension, bump, droop, bumpsteer, toe, curve. We'll look at some rear-wheel drive setups. We'll look at portal and non-portal all-wheel drive setups. We're going to dive into what the steering rack is, rack adapters, steering boxes, swingers, center links, pitman arms, rams, sway bars, and the sway bar links, bars, etc. So those are a bunch of the terms and stuff we're going to define shortly here. And then we can move on into more in-depth discussion and chunk a lot of that stuff out and then go into some core concepts and beliefs and opinions that I have. And now, a lot of what I'm going to be discussing is stuff that has to derive from my experience, guys that I have learned from, stuff that I have designed, stuff that I've fucked up and had to learn the hard way, which, I've been doing this for, design alone for well over a decade. Been building stuff for 20 years. I was doing fab work, etc. Well before I jumped onto the computer and design work. So I started out doing stuff by hand for the most part. And there have been a lot of people that have kind of helped me along the way. And the main guy who really got me going in CAD work was Louis Dietz from Customs Factory. We were business partners at one point in time with our fab shop down in Signal Hill, right next to PCI Race Radios, when they were in that location. And he did push me to get into the CAD design stuff. So I definitely thank him for that, because that was well before it became the primary core for all of what we do in this off-road endeavor. And in fact, we can just give Louis a quick little shout out. So his business, Customs Factory. And he does CAD too, but he is definitely more on the side of like body surface design, and like car shit. And he's EV shit too. He has been dabbling a lot in EV shit. So he's been really into more of the supercar type stuff, where he is designing things along those lines and getting into composites. And he's starting to dabble into some of the printing stuff too, and stuff like that. And we've been doing that too, a little differently. I'm dabbling more on the designing and building printers side, so to speak, for everyone to make shit. And he is you can just see some of the stuff he designs. So he got me into doing the CAD work, etc. Many years ago. And so I've learned kind of by force and some of his recommendation. So that's where I started as far as, diving into from the physical side of the table into the digital side of the table for design development. And then through the years have just learned and worked with a lot of people and have learned from a lot of people, older guys than me that have a lot more experience. So I am by no means God's gift to the off-road industry. I am by no means the end-all, be-all. What I say is the only way to do any of this stuff. What I say is the only way to understand any of these metrics. And there's definitely guys that design outside of the stuff that I do. There's guys who have different opinions that I do. I will highlight some of that. It doesn't mean they are wrong. It doesn't mean I am wrong. It just means that there's so many different ways of doing all this cool shit. And it's really hard to tell who is the quote or, the ideal way of doing this stuff. And as we get into more complex into this discussion, you're going to see that there's a lot of variance in all of these little bits that we can manipulate with these front ends. Even though they all generally look relatively similar, there's a lot of cool shit that you can do. And it's almost like that saying, like any given Sunday, there are trucks that win races that are literally fucking polar opposites as far as these aspects of design, you know, from one weekend to the other. So it's very difficult for me to sit here and say that there is a superior way or method to any of the metrics and things that we're about to discuss over this next mini series of videos. That combined with the fact that I do not claim to be a professional driver by any means to be able to appropriately tell you how I like what feels best in regard to me winning races in said race trucks, because I don't have enough seat time to call myself a professional race driver. You know, there are guys who legitimately can understand the dynamics of these trucks with their ass dyno and appropriately communicate that to engineers and designers. And even with that said, I still feel like that is a small section of the industry too. So again, to some degree, the off-road design development is still somewhat of the Wild West in relationship to what I'm about to review with all of the independent front suspension characteristics, etc. With that said, there's also some sort of standardizations as well. So if you start to go too far outside some of these standardizations and things that I'm about to review, you will more likely than not find yourself in a non-competitive atmosphere in regard to that said vehicle. Now, that does not mean that you can't be competitive if you're outside of some of the things I mentioned. It simply means that the majority of stuff is inside of those sort of standard areas. So, with that said, let's dive in. So, we're going to first review some of the bits with what's what. So, let's start with here's a kit I designed for an all-wheel drive application. This is a Silverado, a new Silverado four-wheel drive setup. So what you see here in blue is what we call the upper arm. So when I refer to the upper arm in a long travel kit, this is a long travel kit. That's what you're going to be thinking of. Green right here is the upright. This is not the spindle. People incorrectly call this the spindle. The spindle is where the bearings ride for the hub assembly. The green part right there is the upright. The spindle is part of the upright assembly. The red is the lower arm. So when I refer to upright, lower arm, upper arm, this is what you should be thinking when I refer to that in relationship to a long travel setup. Now here's another long travel setup. Same deal. This is a setup I designed for Izzy Fabrication. This is a Silverado setup. This is, I believe this is GMT 900. The tan is the chassis, the stock Silverado chassis. The red is the lower arm. The green is the upright. The blue is the upper arm. So again, you just want to know what those are when I am referring to those terms. Upper arm, upright, and lower arm. Now let's go into some center mount terminology real quick. Where did it go? There we go. Okay. So a center mount does not have a stock frame or whatever. Like I was saying, it's different than long travel, and I can manipulate this a fuckload. I can make all my own points. I can do a lot of cool shit with the geometry that you're limited to with the stock stuff from long travel based setups. And with that said, we can move these arms and pivots borderline on center. Now they can't be on center. There's a few complications with that, and for those who are experienced in the industry, yes, I do know what Dave Clark did in Vildosola's trophy truck. So technically that is on center, but you know, bear with me. The vast majority are like this. There's going to be a spread between those lower arms, 3 inches, 4 inches, 5 inches, etc. But they are basically towards the center of the chassis, hence center mount. And what this allows us to do is have a lower arm that's relatively long for the track width, gives us a good amount of travel. And with that travel, we can control it appropriately because, like I was just saying, I get to pick where all of the points go. And in doing so, I create the geometry. The designer creates the geometry, and we can work with a blank slate. That is completely different than working on long travel-based setups where you're working around stock suspension, and that can become a total fucking nightmare. So, with that said, blue is our upper arm, green is our upright, red is our lower arm. Now, in this specific scenario, we have swing set steering. So purple is going to be our swinger steering system. The light blue stuff are our components. This is our steering box. This is from Power Steering Solutions, Charlie. This is the baller billet box that he just released. This is the ram for the steering. This is our shocks. Ram is from ID Designs. These shocks are specifically Fox. These are Fox Racing shocks. The tan here is what we consider the bulkhead center section. This green bit right here poking through, that is actually the front sway bar. I do like to mount them off the lower arm when I can, tuck them under the drivetrain. There are some people that like that. There are some people that not like that. There are some people that don't even fucking like front sway bars and they think they're total shit. So some trucks don't even have them. Again, hit or miss. We're going to review some of those as we get into the more complex stuff. Now, let's look at another one. Here is an all-wheel drive trophy truck front end. The blue is our upper arm. The green is our upright. The red is the lower arm. The purple is our steering system. This orange guy back here is our front differential. This is one of the brand new Albans units. This blue, that is the lighter blue. Same with these bits. We've got our Fox shocks. We've got, this is an ID ram for the steering. This is our box. Again, Power Steering Solutions, Charlie. And this green in the back is, again, a front sway bar. As you can see, I do like that location when appropriate. Doesn't always work, but in this guy, tons of room to run that. It's a mid-engine truck. So now that you understand what those are, that is terminology I will be using throughout this discussion. Now let's go into what the wheel mount surface is. The wheel mount surface is an important number because it's a number that, generally speaking, does not change when you're designing these setups. Wheels and tires can change, and I'm going to dive into that in a second. But let's focus on what the wheel mount surface measurement specifically is. It is the surface at where the wheel actually touches and mounts. In this specific application with this upright, this is a Blitzkrieg front hub assembly. His rotor mounts to the back of the hub, which means the wheel mounts directly to the hub surface. Not to get confusing, this is a PME setup for the rear of a hub. The hub itself is where the wheel touches and mounts. The rotor mounts to the back. Now, to make this even more confusing, there are setups that have a rotor hat that goes over the hub. Mason Motorsports does run this, and I will show you that right now. Let's go over to that. I am going as fast as I can because this is an insane amount of information. This is a 13-page outline. I'm going to do my best to get through. So this rotor hat goes through, which means the wheel then bolts to the rotor hat. So you would take your wheel mount surface measurement from that rotor hat, not the hub face. So that would be the difference in where you take the wheel mount surface measurement. Now, from there you have hub mount surface, which is where the hub itself mounts. These get welded in, so let's look at some uprights. Some of my favorite uprights, another company that makes basically the baddest uprights there are, ID Designs, if you can afford them. But Dave, he makes great shit. That's the bottom line. Perfect. So this is an upright assembly. The snout and hub bolt to that. That's what I have here in my hand. This one's a little different. This is one I sell on DIYoffroad.com. It's a 1-inch thick 4130 Snout Block, and it has the standard 12-bolt pattern, which would be Idanium 44 and race hubs 2.5, etc., etc. So this surface is what would be called the hub mount surface. This is where the snout and the hub will bolt to. On those uprights right there that are ID uprights, you can see where the hub and snout bolt to. Now, that should not be confused with, he also makes, and I have also designed stuff like this too, where the snout welds in to the upright. It gets pressed in and welded. So a little bit confusing, but the point being is that's not necessarily something you need to be worried about because we're focused on wheel mount surface primarily. And wheel mount surface is what's going to dictate the track width relative to what you have for wheel and tire packages. Now, let me look at a quick little diagram from Matt at Baja Customs, who sells his Y-frame on DIY Off-Road. He's got a little thing here. So here you go. Here's a wheel mount surface, and that would be where the wheel mounts. And obviously your track width, which is the outside of the tires, is going to be wider than your wheel mount surface. But here's the important part. Your wheel mount surface does not change unless you swap out hubs, etc. But let's just say when you design stuff, you have your hubs set in mind, you have all the bits set in mind, so that surface does not change. Tires and wheels definitely change, and they can change a decent amount. So you could have the same wheel backspace, i.e., you know, from Vision to Innovate to Method to Raceline, they could all be 4.5-inch backspace, but there's a little variance in where the tire sits centered on that wheel relative to backspace. Then you have the width of the tires when they're filled and the type of tires and treads that can add to or subtract to that track width. So there could be 3/4 of an inch of variance between wheel and tires, even though you have the exact same wheel mount surface for that front end. You see what I'm getting at? So it gets a little bit frustrating sometimes for us design guys, because that shit gets annoying when guys are swapping stuff out left and right, and then they're wondering why it starts rubbing the body or fiberglass because you had, you know, 3/8 of clearance, but that went away when they changed out wheels and tires. Totally happens all the time. So point being, wheel mount surface is a very good measurement to note, and track width is going to be outside of tires. Now, I like to measure track width kind of in the middle of the front of the tire. And yeah, I know there's going to be guys that are going to be like, well, what the fuck? Like, what if it's got, you know, a little bit of toe at ride height, etc.? Well, yeah, I'm not too worried about that. It's a generalized number because, for fuck's sake, you're going to have camber in there, and we'll get to that too, but that's going to create a different number from the top of the tire to the bottom of the tire anyways. So if you take a generalized number from the middle of the tire at the front, that's just a good way of doing it because it's easy to compare day to day with the same vehicle, so to speak, as long as you're not drastically changing what you set your toe to at ride height. But yeah, so just a good way of doing it, and typically fairly easy on this truck, so you can get underneath it, measure it pretty quickly. It's borderline impossible to measure the top straight across with all this shit in the way, stuff like that. But yeah, so with a little bit of camber in there, you're going to have a different measurement for track width on the top than you will at the bottom. I like to take it in the middle, and we'll call it good there. So now, wheelbase is the length of the chassis, so to speak. And so let me pull up one of our chassis to show some wheelbase shred. Okay, so wheelbase is going to be the distance, you know, at ride height. Again, you do not want to do this away from ride height, but center point of this guy to center point of this guy. And the wheelbase will change through travel. This you're not going to be able to get away with. As the rear suspension cycles, at compression, it's going to shorten up wheelbase. At extension, it's going to shorten up wheelbase. Now, in the front of the truck, whether you have rake built into it or not, if you have rake built into it, the wheelbase will slightly change through travel. If you do not have rake built into it, the wheelbase will not change through travel. So, with that said, here's a funny tidbit. There's guys that design bodies, etc., and they'll set up the bodies with all the fucking suspension at full compression, which we'll get to, what some of those terms mean. And they don't pay attention to the fact that the housing will shift rearward at ride height from compression. And when it does that, you end up with a wheel well that looks off at ride height. And it's just a weird thing that bothers me. I like the wheel well to look centered at ride height, and then when it's at compression, it'll be a little bit towards the front of the wheel well. But I feel like that's better than having the wheel well off at ride height but centered at compression. Again, just something that it annoys me when it's not centered at ride height. But you know, different strokes for different folks. So that's wheelbase. Now let's go into camber. Let's do the good old Google for camber. See what Google does before I pull up what I have. I'm going to do off-road truck because, you know, I don't want to pull a ton of stuff from other bits. Let's see if there's a diagram that pops up. Here we go. It's a UTV, but good enough. Good enough for government work. Oh, and they have it correct. Even better for government work. So, negative camber. The tires are leaning inboard at the top. 0, obviously straight. Positive, the inverse of that. Positive, kind of the no fun zone. There's some debate in that, but personally, I'm not a big fan of that. Why the fuck UTV? I mean, I know why the UTV OEMs intentionally designed that into the systems. I do know why some of the Ultra 4 guys designed that into systems. I'm just not a big fan of that myself. But different strokes for different folks. So that is camber. Let me show you what one looks like on this. So again, you are measuring camber. It's the angle relationship of the tire to the chassis being flat. A properly set up truck is going to have some negative camber at ride height. How much negative camber? Well, we'll dive into those and camber curves and stuff like that. But the point being is right now you need to understand what camber is. When I refer to camber, this is what I'm referring to. When you're looking at the truck head on, it's the lean of that tire, and it should be in that direction. Should be. Now let's go to caster. Well, let's Google that real quick. Let's see what comes up. Just for shits and giggles. Off-road truck caster. I mean, it's the same shit for car stuff too. I just want to see if there's any if anyone has off-road diagrams put up. What is that? That's more car stuff. Well, the point being is, we can just look at mine. Cool. The point being with caster is, you're looking at the vehicle from the side. The top pivot of your upright is going to be further rearward in the chassis than the lower pivot. Should be. I'm sure you might be able to find stuff that's not that way. In other words, the caster is the wrong direction, where the top of the upright is too far forward in the chassis. But let's just assume that everyone is doing it in the right direction. And the arguments then can carry on to how much. And we'll dive into some of that stuff and my thoughts on that too. But the point being is, when I refer to caster, this is what I'm referring to. When you are looking at the vehicle truck, basically from the side, you can envision those two pivots. The top one is further back in the chassis than the lower. That is what is creating our caster. Oh, an important note. So there's inconsistent caster and consistent caster. There are a few different terms that people use for this. I like to prefer inconsistent and consistent. I feel like that's the easiest way to describe it to clients, easiest way to describe it to racers, builders, things along those lines. And what that means is, as the suspension travels up and down, consistent caster is just that. It stays consistent. So whatever you set that to, it's going to move at that angle and degree. Inconsistent caster, however, will change through travel. And typically speaking, what we do in some setups, not all of them, is we do inconsistent caster in a relationship where it gains caster at compression and loses caster at extension. The way that's done is by diving the upper arm. So the upper arm pivot will be at a steeper angle than the lower arm pivot. So this front pivot of the upper arm will actually be higher in the chassis than the rear pivot of the upper arm. So you have your lower arm and your upper arm is flat, and that is consistent caster. So in other words, they are parallel. With inconsistent caster, you have the upper arm at an angle relative to the lower. And that's going to create a situation where the caster changes through travel, and you would add caster at compression, you would decrease caster at extension. Now, how much you change that relationship, again, just like all of this, is up for debate. And there are various schools of thought from different builders and designers like myself on how much is too much, how much is rad, how much is really fucked. all those things. So there you go. So when I'm talking about caster, when I refer to inconsistent or consistent caster, because we will dive into that in the caster section. Now, let's dive into inclination, another one of my favorites. Open. Let's do a Google on that too. Let's see inclination scrub. Let's see what comes up. Not terrible, not terrible. That's not a bad one. Scrub radius explained. I don't know who these... I mean, I've watched some of these other YouTube videos. Most of these guys are like, meh. Like, they kind of generalize some of the terminology, or they're close. But very few are actually, like, legitimately designing this stuff on a day-to-day basis. And I just realized the irony in talking shit on other YouTubers while putting this on YouTube. Good old race desert stuff. There's going to be conversations on that. But yeah, we'll just go with my diagram. Make it simple. So, inclination angle, kingpin inclination angle. We're looking at the upright and tire assembly head on. So if I was to kneel down and stare directly towards the front of the truck. This is, again, for long travel and center mount trucks. These terms and shit, this all applies the same. The red line is our inclination. That goes through the upper and lower pivot of the upright. And then it's going to touch the ground. Now, you'll notice I have a little green line that is about an inch and a quarter or so. This is a 42-inch tire. Above where the bottom of the tire is. Now, that represents ground. What a lot of people, unfortunately, a lot of designers do not factor in is tire squish. Your contact patch for a tire like this is not the actual diameter of the tire, the actual radius of the tire from a certain point. You're going to have squish, depending on air pressure, etc. So you have to account for a little bit of that. I like to suck that up a little bit. So we'll, like in this one, this might be an inch and a half, roughly, but the point being is you have to account for tire squish in any of these applications. If you don't, you're going to have an inaccurate scrub and inclination relationship. The green at the bottom, right down here, there's going to be a distance in there where it's touching the ground, the contact patch. The blue line is our center line. So you have center line of the tire coming down to where it contacts the ground, and you have the inclination coming down where that contacts the ground. And there's going to be a distance in there. Now, that distance can be bigger, it can be smaller. Again, I'm going to go through some of that, some of the schools of thought on that. I just want you to understand what it is I'm referring to when I'm referring to inclination and scrub. This is the specific aspect of that terminology. So we go now to Ackerman. So Ackerman is a steering characteristic, but and it gets a lot more complex than what we're about to go through. But this is looking straight down in the chassis. Now in off-road, Ackerman isn't really calculated like it would be on a road race car, primarily because the way to do that in a road race car, it just doesn't apply to off-road. Off-road trucks move. We're in dirt. We slide. Traction is not the same. It's not fair to apply the same principles to some degree and assume that you're going to have the similar outcomes. So the best way I like to look at Ackerman is how much does said client or racer like the vehicle to feel in relationship to turn speed, interior, exterior. And when I say turn speed, that because what happens with Ackerman is the interior tire is going to turn faster than the exterior tire because you are adding Ackerman into the system. The more Ackerman you add, the faster that interior tire will turn. Ackerman is the relationship of the steering pivot. So in this example, the red is the steering link. The steering link that's on the rack mount or chassis side is further rearward in the chassis than the pivot point on the upright side. And that creates a relationship as it turns to where the inside tire will turn faster than the outside tire. More Ackerman you have, the much faster it turns. Less Ackerman you have, they turn closer together. Reverse Ackerman, well, it's the opposite. The outside tire will turn faster than the inside tire. Sometimes you can't get around that, and I will dive into that into more specifics, but I want you to understand what Ackerman is when we are talking about that, and that is the relationship, and this is an off-road vehicle. So in a road race car, there's different ways to look at this, so to speak. They're a little bit more advanced to some degree, and in the off-road stuff, I like to keep it a little bit more simple for clients and for racers to make it easier to understand, and that is the relationship of the pivot in the chassis depth-wise, front to rear, relative to where it is on the upright front to rear. And as you can see in this, the chassis side is further rearward than the upright side, giving us an Ackerman number and giving us a higher speed interior on that turning relationship. So now that you understand what Ackerman is, let's go to CPTC, Contact Patch Trackwidth Change. A little bit more of an advanced thing, but again, it's important. And I like to talk about it because, and I'll go in more depth of this, but CPTC, Contact Patch Trackwidth Change. As the vehicle cycles up and down, and here's two different setups. This is a trophy truck. This is a luxury pre-runner I did for a client. And we'll dive into more depth. But what I want you to understand is what I'm referring to when I say CPTC. That is a dimension. So you have this width here. So you have a contact patch. These are ride height. This is compression at the top, and this is extension at the bottom. So this would just be mimicking in snapshot form the wheel moving up and down in the chassis. There's a center point of where the tire contacts the ground, the contact patch. As you cycle the suspension, that contact patch track width actually changes, and it can change a fuckload if you're not paying attention, or if you have a client that's just straight up doesn't give a shit. It'll change a lot. I myself in the school of thought to mitigation of that, but again, we're going to dive into far more depth of this. I just want you to understand what CPTC is. Now, that change in there, like I'm saying, is measured with the contact patch. So that's where the tire is touching the ground to like the center point of the chassis, or you do, from both sides. So if both sides are cycling, obviously that's going to change. How much you let that change, whatever, we'll dive into that. I just want you to understand what it is and where we're taking that measurement from as we move forward. That is contact patch track width change, CPTC. Now let's go into what seems to be a lot of the internet guys' favorite for some fucking reason, is Bulkhead Rake. And an argument too. Like you see guys arguing about this shit even on like fucking Facebook. Goddamn children. I mean, it's no different than the bullshit we used to do like on DR and what still happens on a race desert, to be fair. A bunch of men, well, I used to be a kid, but a bunch of men now basically just running their mouths on stuff like this. But Bulkhead Rake. So rake refers to the angle of the lower arm pivots relative to the chassis. And I say relative because the chassis can be weird or cattywampus, so we're just going to say if there's like a chassis flat level plane, the bulkhead would be the rake of that. So the top image here is of flat bulkhead. This is one of our stage 1 luxury pre-runner chassis. So this has 0 degrees of rake. That lower arm is literally flat to the bottom of the chassis. See a lot of trucks like that, et cetera, et cetera. And we're going to dive into, again, I just want you to understand what rake is. I'm going to go far more in depth into this bullshit as I go through this discussion. The one in the middle is 4 degrees of rake. So that lower arm is raked up 4 degrees relative to the chassis. The bottom is 8 degrees of rake. Again, lower arm is raked up 8 degrees relative to the chassis. So I just want you to understand what rake is. That's it. Now let's go to wheel travel. And we can bring this up again. Or I think I have another cool one to show. So here's one. This is just something to look at. These are different suspension cycling. So wheel travel is done in a few different ways. So you have what's considered usable and metal-to-metal. Metal-to-metal travel is how far... So if you were to remove the shocks from the system, metal-to-metal is where you will have some sort of final stop with the suspension, i.e. something's going to crash. Lower arm is going to hit the upright. The upper arm bearing is going to max out. Steering will max out. Something will max out metal-to-metal. And metal-to-metal is always going to be greater than usable wheel travel. If it's not, you've got a fucking problem. And they shouldn't really be that close. There should be some space and a buffer zone between them. And we'll get into more specifics in that with the shock section. But I want you to understand the terms. Usable wheel travel means the wheel travel is actually being used. So that'll be bumped and strapped wheel travel controlled properly by the shocks. Metal-to-metal can also be used to denote the bypasses metal-to-metal measurement of the shock stroke length in the system. So, for example, I'll set a lot of trucks up like the ones you see here. They're right around 24.5 inches of metal-to-metal travel, and they will be bumped and strapped at usable 23 and change, or 24 if we're edging it close to that metal-to-metal zone. So those two numbers are very important. Usable is the most important, and you need to understand the difference between those two. Moving forward, there's going to be 5 aspects to the suspension travel and movement. At the top here is what I call compression. Compression is just that. The suspension is fully compressed. The middle would be considered ride height. Variations in ride height, so just you know, there can be variations. And guys like to move ride height in the travel relative to compression, etc. So they may have more compression or less compression relative to extension. Extension is the bottom side of travel, the bottom row, so to speak. The reason I like to use these terms, because you do not want to necessarily interchange them with bump and droop. That would be kind of inappropriate on an engineering standpoint. So when you're saying compression, you are referring to it actually being compressed, like full compression. When you're saying extension, that would be extension on the bottom side. If you go to the shock manufacturers' websites like King Shocks, etc., they actually denote the shocks in that fashion as well. So again, it's more of an engineering terminology. Now you also hear bump and droop. And here's why I don't like using those terms unless you're specifically referring to bump and droop, because compression, extension, and bump and droop are not the same thing. Bump is part of your compression travel. Droop is part of your extension travel. And here's why. And this is my opinion. This is what I like to use to make things less confusing when dealing with clients and dealing with setups. The bump zone of your compression travel is going to be the last several inches of travel, and the bump zone will be a little bit less than full compression, so to speak, because you're going to be a little conservative on saving that bump stop from crushing in on itself. So when you talk to bump travel or bump zone, that's really only a few inches of the top side area of compression travel. So when you're talking about from ride height to fully compressed, that's compression travel. When you're talking about the section of movement that comes into compression travel and then gets towards the full compression, it's going to hit your bump zone and then final out. And that's going to be bump travel. Now, droop. I like to use the term droop in relationship to the limit straps set up on the extension side of travel. And what I like to call the droop travel joint is where if you have the truck in your shop and it's just static and you let it hang on the limit straps, that's the start of your droop travel. The end of your droop travel will be at strap stretch under load. So when you're out racing, etc., and you're coming through stuff at speed, the straps will stretch more than you see in the shop. So that chunk of travel is what I'm referring to for droop travel. So droop is going to be that final or last area of your extension travel. Again, this is just how I like to denote these sections of travel and terminology. Some people might refer to them differently, but to simplify things and I think to do it properly, I like to use this terms: compression, ride height, extension. Bump is a stage of compression. Droop is a stage of extension. Okay, so now we're moving on to bump steer and toe curve. I like to refer to it as toe curve. I just, the bump steer part of it is just, it seems dumb to me. But let's go through this. So bump steer is the movement of the tires as it cycles through travel. And what that means is if the steering geometry isn't dialed in how you want, so to speak, in a nice toe curve, it's going to be a little cattywampus. And when it gets let me just show you real quick. I was just thinking of something because I just got a message from Craig, actually. So Craig Hall, another great designer. Let's give him a little shout out real quick. And I can showcase exactly what I'm about to refer to right now too. There we go. Shitting all over the UTV guys. I love it. So if you look closely, this car is towed in a decent amount at full extension. So what happens is as the suspension is going to an extension travel, the tires, instead of them both pointing straight, are going to start to point where they're towed in. So that means that the distance at the front of the tire is less than the distance at the rear of the tire. And what this can do is cause it to be darty and kind of steer for itself to some degree, irrelevant of what you are putting feedback into the steering wheel, hence the term bump steer. Also, some positive camber fuckery. Again, Craig, he's on the same page I'm with this. This is not rad by any measure. So definitely don't want that way. But the point being is bump steer is the relationship as the wheel and tires travel, whether or not they move inboard, outboard through travel and create some sort of weird steering that you are not inputting. In other words, it's steering itself. You're leaving the wheel straight, but the geometry is off, so it moves. And I don't like to use that because, newsflash, zero bump steer is incorrect as well. So anyone doing that, oh, I have zero bump steer, I designed that, it's just like kind of a red flag that like they don't know what they're talking about. Because that's, and I will dive into that. But here's the hint: toe curve. This is where we're going. You want a consistent and controlled toe curve, not zero bump steer. Anyways, so you got all that terminology down. Let's jump to what a steering rack is, and show you what I'm referring to when I say steering rack. Close out these guys. So again, I'm just trying to go quickly to get through this first chunk so that we don't create a situation of 900 fucking hours. But boom. Okay. So this is a rack. This is a Power Steering Solutions 275 rack. This is our rack adapter. So when I refer to rack setups, this is the unit that is steering the vehicle, and it moves in a linear fashion side to side. It's literally a rack and pinion that's powered, so to speak. So big difference between this and swingers. But I just want you to know what a steering rack is and what the steering rack adapter is. Now let's go into steering box. Cool. This is a stage 2 swinger setup. This is one of the designs I sell on DIY Off-Road and some bulkhead assemblies. So here is our steering box. This happens to be from Charlie at Power Steering Solutions. But let me show you some stuff that's a little bit more normal, or what you guys probably see all the time. Let's see. or no, let's look at Instagram. Let's see if How, HOWE, How Performance. Another good company. God, we have a ton of people that run How stuff. Let's see if he's got pictures of any of his Saginaw boxes. Because before Charlie came out with his is a billet one, Charlie's. And I'll show you that here in a second in real life. Oh, come on. God damn it. Watch, he does not post any of them for some reason. Just my fucking luck. Well, we tried. Anyways, How Performance, they have a lot of good stuff. So, Power Steering Solutions. This is Charlie. There we go. Again, so here is your steering box. These are more or less a Saginaw box, but they're not a Saginaw box. These are completely done from the ground. So the big boy trophy truck stuff is running this box. It's a billet box that is very robust. That's what this is in here in my CAD assembly. So I just want you to understand what the steering box is. And these are the swingers. So red is the steering swinger. Green is the steering swinger. Red is the driver's side in this specific example. Green is the co-driver or passenger side. The blue is our pitman arm, and we'll dive into more specifics with this stuff. This guy back here is actually the ram. So that is an ID Designs ram. This tan piece would be our Centerlink, dog bone, etc. Yellow is the actual tie rod going out to the upright. Excuse me. And so that's, again, this is kind of a good example of like a generic steering swinger setup. This is on our stage 2 stuff, stage 2 bulkheads. But we'll dive into, we'll get far more complex with this stuff down the road. I just want you to understand what the specific pieces are so that it doesn't hopefully get too confusing as I move forward. Let's go over another swinger setup. This one's a little bit more complex. Not really. I mean, it's a similar principle. So the driver's side swinger is this big mamma jamma. Passenger side swinger is this green. The blue is the pitman arm. Again, this is Charlie's power steering box. This is an all-wheel drive trophy truck setup, so this is an all-bends front differential. This tan here is the Centerlink. The yellow here is the toe link that heads outboard to the upright. This is an ID Designs 2 1/4 inch ram, pretty sure. And so again, I just want you to understand what these components are when I start referring to them down the road. Now, see if I've got, we'll go to sway bar stuff just so you can quickly dive into that. Okay, so again, front sway bar stuff. Some guys like them, some guys don't, but that's irrelevant. We will dive into that. But I want you to see what's up. The sway bar is actually a bar that goes through this chassis underneath the drivetrain in this specific truck. This is, and so that would be your bar. You know what I mean? That's the part that you would be ordering relative to length and sizing. 1 inch, 1 1/4 inch, or 1.5 inch, different variations of threads. And we'll dive into details on that. This is your sway bar link. And so typically it's going to be rod ends on the front setups, 5/8, 3/4. But again, we'll dive into more of that. And this is the arm. So this is your arm itself. So when I say sway bar arm, I'm referring to that sort of piece that then connects the bar to the link, which then connects to the arms. So just want you to kind of see what that is. So now that we've gone through a bunch of these definitions, let's review what some rear wheel drive front ends look like. Let's go through that. Cool. So this is a very unique one. Starting off with something really cool. Ryan Arciero's VW Touareg. Again, this is a rear-wheel drive setup. It's got some cool stuff going on here, but I just want you to see some of that. This is the original Blitzkrieg trophy truck. Nate Hansen designed this, built at his shop for Adam Householder. And again, just want to show you what rear-wheel drive front ends look like. Here's uprights, upper arms, lower arms. This is a rack steering setup. So here's our steering link, toe link, etc. Here's one of the original Camber designs. This is older. Their new trucks are definitely different. But again, just want you to see some of what I'm referring to. This is an ID Designs front end and steering swinger setup. So again, another good example of a rear-wheel drive front end. This is a Missoula truck, and for some reason I didn't do a good job showcasing the front end. But again, another good example of a front end. This is the front of an Alumacraft 6100 truck. So you can kind of see the tube structure and the bulkhead forming. For obvious reasons, the suspension's not on yet. This is the front of a Mason truck. This is a non-all-wheel drive truck. And so this is a rear-wheel drive Mason. They do. I know they're famous for the all-wheel drives, but they have some pretty bitchin' rear-wheel drive trucks too. Here is one of the steering boxes I was referring to. Here's that same truck. So this is a Mason rear-wheel drive platform. This, I believe, is a Racer Engineering platform. It's a rack-based setup. So obviously here is your rack assembly. Here is your lower arm, your upright, and your upper arm. This is another Mason. This is a Mason two-wheel drive. Again, another shot of the Mason, so you can kind of see what's going on to some degree. Here is another one of Blitzkrieg, Nate Hansen's front ends. I don't know if this is Householder's truck. It does look like it. Looks really close. But again, just want to show you some bits on that. This is Householder's truck. This is the original Camber trophy truck. Again, just wanted to show you some bits on that. This is a Jimco. This is a little bit older Jimco, but still pretty rad. And again, just want to show you some bits. Same Jimco. It's a rack style truck. ID Designs front upright. This is a Geyser. Of course, you have to have Geyser in this stuff. I mean, they're legends. The brothers are pretty rad. And again, just a good shot from underneath of what a rear-wheel drive bulkhead stuff looks like. This is the Camber truck. This is the original Camber truck. Their stuff has changed a little bit, so to be fair, it's not like this anymore. They have some different aspects to their design, but generally speaking, it's still very similar. This is the front of a Geyser truck getting started. So you can see the bulkhead forming and the tube structure coming down in the front end. This is where the rack would mount to this plate right here. Your upper arm pivot is starting, and your lower arm pivots. This is Robbie Gordon. Holy fuck, does he look young there. I forgot this picture was in here. And a good, there you go, fucking Caltime metals. When I was doing fabrication, I used to buy everything exclusively from Caltime. Bitchin' guys down there. And you can, I know exactly what that is. But that is part of the bulkhead up front. You can see this is many years ago when they were building this stuff. And some pretty innovative and gnarly shit, man. These were V-drive trucks, mid-engine, just rad. I mean, the talent that Robbie had surrounding him was fucking cool. Here's that truck. And again, just another way of doing it. Again, this is more odd, so to speak. So this is different, and there's a lot of guys that do not build stuff like Robbie. Robbie definitely does things differently, and in a cool way. This is another Geyser front end. So another great example. This is the front end bits from an Armada front end, which, you know, Armada, so Igor, I believe, designed this stuff. So Igor is Triton Engineering, and he split off. I can't remember the individual's name who owns Armada. and I feel like an asshole. But the point being is Armada and Triton, they were two guys together. Then Igor left, and now he does Triton Engineering. But there's still very similar stuff. Another Geyser front end, a Jimco front end, a Cartech upright. This is a luxury pre-runner with a stage 2. This front end I designed before DIY even existed. So this is a little bit older. But this truck actually is still running pretty fucking hard with these parts and components. The current owner of this truck has been racing it, and he's been winning races, ironically enough, in it. Some local races and stuff. And he just did the Nora 1000, which was like 1,300 miles. He came in second, I believe, in the class. Or maybe first in his class. I'd have to check on that. But they beat the fuck out of this. And I actually just redesigned. So the guys that own this truck now, I just redesigned their trophy truck front end and rear suspension stuff. This is another front end. This one I designed for the owner of King Shocks, Ross King, on his luxury pre-runner. Same deal. This is Ross King's front end. This is a plasma table friendly stage 1 front end for trucks. This is a design I sell on DIY Off-Road. This is a really cool thing that we do for plasma table friendly stuff, but again, a good example of a rear wheel drive front end. Another example of a rear wheel drive. This is a plasma table friendly setup. I don't want to say budget. It's more like entry level. This is perfect for the dudes who have never built this stuff before and have a plasma table and they're ready to rip. Again, same deal. Same deal. This one's a sand truck version of a plasma table friendly front end. Sand truck version. This is the SST trucks. Yeah, Gordon would be mad about showing those. But this is the front of the SST trucks. This is a plasma table friendly buggy front end. I know I wasn't going to do too much buggy stuff, but this is designed around that Cartech upright, so just kind of hinting on some of the buggy stuff. Very simple buggy stuff. Buggy stuff. This is a trophy truck front end. This is our T4 front end. This is one of my designs. I do sell this design, but again, a good example of a rear-wheel drive front end. And yeah, so there's rear-wheel drive front ends, kind of in a nutshell, just to give you sort of a nice little glimpse of a bunch of different styles, and we're going to go into more detail on all those bits as we move forward. So let's go through all-wheel drive. Now, the all-wheel drive stuff is like the new bee's knees of everything. Because they're fucking winning. I mean, Mason's been doing a great job of dominating to some degree with those. And there's two variations of all-wheel drives. There's portals and non-portal all-wheel drive trucks. Portals are more expensive to design and build. Non-portal setups are cheaper, easier to design around, and easier to build, so to speak. And so we're going to go through those variations real quick. So let's start with the cheaper stuff, the non-portal front ends. And let's just review what those look like before we go into crazy amounts of detail. This is Igor from Triton. This is a non-portal front end he designed for like a rock racing type of setup. So I guess you would say like some KOH-based sort of stuff. I think he uses Spiretrax components in this. I use Spiretrax stuff too. It's pretty rad for non-portal stuff. But the point being is the axle is on center line of the hub and the lower arm mounts below that assembly. That is the key, and keep that in mind as we go through this. This is, I forget why I put this picture in here, but this is a concept from an electric all-wheel drive deal. I spoke with the guys at this company. It's a Geyser is doing it with them on this electric all-wheel drive platform, and the guys that are designing this front differential, how do you say it nicely? They don't know what they're doing. I had some technical questions for them, and unfortunately they were like deer in the headlights. They got to definitely rework that front differential if they want this to be viable. For starters, the CV center point of that is like 10 inches too wide. And if you've designed, any of the other designers that might be watching this, you know exactly what I mean and how fucked that is for designing an all-wheel drive race truck with a fucking CV center point that's fucking massive. But hey, it's electric. So don't mean to shit on people, but it's just sometimes you just gotta shake your head. This, ironically enough, is a Geyser all-wheel drive. So it's nothing against, just to be fair, this is nothing against Geyser. Nothing against Geyser. It's just the guys doing this electric front diff are just, they completely missed the mark for any fucking thing off-road related, unfortunately. So this is a Geyser non-portal setup. Axle right here, as you can see, is on center line of the wheel and hub assembly. So it's basically a one, this is a direct drive. This guy's driving right into the drive plate or drive plate assembly of that hub assembly. The lower arm is mounted below that. So for obvious reasons, you've got this relationship of the axle, hub, and the lower arm. And like I said, keep that in mind. This is the Herps all-wheel drive trophy truck. So no, Mason is not the first to do an all-wheel drive trophy truck. That is a misconception that we're going to put to bed right now. Although Mason's is really badass, so I don't mean to detract what Neil and Robert have done. It's fucking amazing, the results they are getting, et cetera, et cetera. But Herps did do it many years ago, and there were a few others that dabbled as well. Back then, the technology wasn't as rad, so they didn't get quite as great longevity, wheel travel, or steering characteristics like we can get today. Nonetheless, really fucking talented guys that did this. Really cool truck, if you can find some stuff for it. This is a non-portal setup I designed for a rock racer. This is actually for Jake Berkey's buggies. I don't know if you've seen those things. They're fucking wild. And this is a setup I designed for him. And I'll go in more detail in this too further on. But this is a rock racer little buggy setup. It's a non-portal all-wheel drive front end. There's the Geyser again. This is Nick Nelson. So again, another dude who built a four-wheel drive trophy truck before Mason. You got to give the dude fucking props, man. I don't know. I've never met him. I don't know the story 100%. I believe he fucking did this shit himself. But it is a non-portal setup. And he had like fucking 800 horsepower. I mean, this thing got down. I've seen some videos of it. Excuse me. And so no slouch, but you got to at least hand to the guy for fucking going for it, So if you Google, you could find Nick Nelson's. This is Robbie Woods. Again, a non-portal front end. I know he calls it the $1 million pre-runner. I get that. I don't know if he does it in like an ironic sense, but this is just unfortunately not that expensive to build. The way he did this, etc., is fairly generic and relatively inexpensive to do as far as an all-wheel drive truck goes. He does have some cool quality. Like if you look at the fabrication quality, it's pretty rad. But there is definitely gnarlier stuff in regards to all-wheel drive, and we'll dive into that shortly. But again, another good example of something that's a little bit more on the budget side in reference to all-wheel drive vehicles, and it's still pretty cool nonetheless. This is just a Silverado long travel kit that I did for some of the newer Silverados. It is all-wheel drive. It is a non-portal all-wheel drive. The axle assembly, again, is on center, lower arm mounts below. So again, just another example. This is a stage 1 all-wheel drive front end that we sell on DIY off-road. So this is, again, a very great entry-level type setup for guys who have a plasma table and want to MIG weld the shit out of stuff. Or TIG weld it, fuck, I don't care. But these are non-portal all-wheel drive front bulkheads, and we sell the cut files for these if you want to build your own. I know that's a shameless fucking plug, but this is a good example of a non-portal all-wheel drive setup. This is designed around spider tracks, builder bells, and center section with a power steering solutions rack. Charlie's rack. If you can't tell, I've been a fan of the PSS racks for the last few seasons. Good stuff coming from Charlie. Spider track stuff is still pretty rad. So that was a good roundabout of what the non-portal setups look like. And so you can kind of understand the relationship of those in the game of all-wheel drive. They are typically going to have less extension wheel travel. That's where you run into the problem mostly. So in other words, you will have less wheel travel overall, typically speaking. You also, to get that wheel travel, you kind of got to sacrifice some geometry characteristics because it's a non-portal setup. So again, not as rad. With that said, these are far more economical. So all those different, examples I showed you, although there's some variations in cost, like obviously Robbie Woods' stuff is more expensive than our Stage 1 stuff, like clearly. But they're still in the same genre in relationship to all-wheel drive setups in the fact that they are on the more budget side because they are a non-portal setup. So it is what it is. They're still pretty fucking rad, and they can still work really well. So you'll see a lot of this stuff with, hopefully, like, these guys are going to be building this type of shit more. And we've sold several of these, but Ultra 4 type guys, a lot of this is there. And guys are starting to transition to portal setup, but again, we're going to dive into more of this in detail. I just want you to understand what these look like and when I'm referencing this stuff. So let's go to portal setups. And first, let's review what a portal is. Fortunately for me, Quinn has sent over some PDFs on his portals. 74 Weld is a company that does make portals. And we're going to review 2 variations of portals. So this is what a portal looks like. That's a good one right there. This is where the CV, etc., comes in. So the axle, then it goes to a gear set that transfers then downward in the relationship of this. It would transfer down to the hub center line. And what this allows us to do is mount, well, this is more of a portal that's based around live axle stuff. So this is a 2-gear portal. And again, I'll go into far more depth in this, but let's look at the 4-gear portal one. So 4-gear portal is more pertaining to the high-end off-road stuff. And what this allows us to do is have the CV up here. So the axle actually enters the upright, and then it goes through its set of gears, and then it goes to the hub. What this allows us to do is mount the lower arm in a relationship that is far better than with a non-portal setup. And this gives us a few characteristics that are rad. So let's go to portal front ends. Open. I just said that as I clicked. I feel like an idiot. So these are Mason trucks. Mason right now is winning. Mason is the guy to beat. All the cool kids have Masons. The country club crowd, as we like to call them. You will notice one thing that is a big difference between portal setups and non-portal setups, and that is the relationship of the axle and the lower arm assembly. Your axle now enters the upright further up. The lower arm assembly is below that, but the lower arm is now on center with the hub assembly, which is the same that we have in rear-wheel drive setups. What this allows designers to do, builders to do, is provide a setup like this that has better ground clearance, a cleaner or more appropriate cycle with your camber curves and other characteristics, as well as giving you better travel. Because what's going to happen is you're alleviating some of the CV fuckery at extension that then gives you appropriate wheel travel. With these portal setups, we're getting a cleanly cycling 24-25 inches of wheel travel with similar track widths as rear-wheel drive setups. So we're basically back to being in the same ballpark as a rear-wheel drive setup, but with all-wheel drive. This is the game changer at the moment. This is what everyone is working towards and racing towards, no pun intended. Mason right now has done the best job of getting trucks to market reliably and winning races, period. They did a good job. It's that simple. So let's keep going so you can see some other stuff. Here's one I designed, and it's a portal that is still the same. It's a 4-gear portal setup. Upper lower, but it's the same theory. We're able to get the lower arm on center of the hub. These are running wide 5 hubs in this specific application, and it allows us to do exactly what I was just referring to. A little bit better geometry. We're back to more normal normal geometry for these types of setup, like the rear wheel drives. We're back to normal travel. So compression, ride height extension is mimicking the rear wheel drives that are competitive. And we have better ground clearance. So we don't have a lower arm that's shoved underneath that center point of the wheel and tire. And so that is all a huge advantage. So I just wanted to showcase what all-wheel drives look like, portal and non-portal type setups. Now that kind of gets us through the section that is all of the generic definitions to get us started in our discussion. So if you're still fucking here for some reason listening to this, thank you, but we still have a long ways to go. So that basically only gets us to right here on page 2. So we're not even halfway point on page 2. Now we're going to start the section that I have noted as starting design. And this is a conversation about where I like to start design with different setups. Long travel is what I'll start with. So when we have someone that calls me, and my clients for this specific avenue are builders, typically, that want to manufacture long travel kits. Occasionally we will get like a dude that wants a one-off stuff, or a builder that wants something one-off for a platform, F-150, Silverado, whatever you want to call it. But what we're doing is designing a setup per certain goals and specifications of the client. So first and foremost, we have to outline everything that that client desires in the long travel setup. This is going to pertain to wheel and tire packages, shock packages, Trackwidth, Wheelbase, because there can be Wheelbase additions, theorized or the goal for wheel travel, and then characteristics of geometry. Now, the characteristics of the geometry type stuff, it becomes difficult in long travel setups to some degree, because you can't be too picky and choosy, because you're still working around stock platforms that have limitations in one way, shape, or form. So just keep that in mind. With long travel setups, you're going to be fighting it a little bit more, but whenever you're dealing with a client or designing stuff for someone that's a long travel based setup, you always want to start with the goals in mind and the specifications that the client wants. They're all kind of different to some degree, even if it could still be the same fucking Silverado type kit. So what I'd like to start with on these is tire hub, brake package, Trackwidth. So you're going to get the tire hub assembly, wheel assembly. You're going to get those picked out, roughly what the client wants to run. From there, you're going to be able to kind of denote the Trackwidth, an acceptable Trackwidth in the chassis. So you're going to take your setup, place those bits where you want relative to those specifications from the client. Now, I'm just walking you through sort of like a basic outline of kind of how we've done a lot of long travel setups in the design format. Sometimes you have certain specifications, etc., that deteriorate that format. So in other words, you kind of just pick and choose and just start throwing some stuff at it and get it cycling and get it going and tweak and tweak and tweak until you're happy. So I'm just kind of giving you just like a quick rundown on how I've done it many, many times. So from there in the computer, you kind of place your hub assembly where you want, and you kind of don't focus on inclination yet. And this is where it differs from center mount type setups. On the long travel stuff, you can use the inclination variation to help other aspects of the assembly. So I can manipulate the inclination. I can add more scrub into the equation to help take some of the negative aspects out of the camber curve or caster curve at some point. So that's why I don't necessarily focus on inclination to start with when it comes to long travel setups. because that's just something that you can typically manipulate more than you would in like a center mount setup, generally speaking. So from there, you get that in place. You would then mock up shock package and lower arm to get it cycling to some degree with like an upper arm mocked in place. What I like to do is set up a generic inclination. So we'll just call it like, on a lot of long travel stuff, we'll just throw it up to like 2 inches of scrub to start. Just see from that point moving forward. And get our upper arm mocked in place. Double check our compression travel and our ride height and our shock package, because we're going to start the shock package at compression travel. And then we're going to start cycling, and we're going to start tweaking from there to the client specs. So let's say it's a Silverado where they want 18 inches of usable wheel travel. So I want that thing to be metal to metal on the bypass, probably like 18.5 to 19 range, so they can bump and strap it a little conservative. So let's say that's our goal, 19 metal to metal. So then you start cycling it. And when you're cycling it, you're going to then focus on your camber curve, so the curve of your camber stuff. You're going to focus on the caster, where you want to set that up. And then you're going to focus on Ackerman. And CPTC doesn't come into the equation too much, because sometimes when you try to work with that, you're just going to fuck stuff up in these long travel kits. Typically, you're going to lose a lot of wheel travel. And I'll get into depth in that in a little bit, but we kind of have this 5-degree rule to start too, which is a good way, I've told like Jack, who works with me, etc., to start mapping stuff out. And what that is you set your lower arm, your inclination at ride height, take your upper arm, and just go 5 degrees down slope towards the chassis, and start there with it, in theory, as long as you can to the chassis. So in theory, just start there. Then you can start cycling it and see. Now, we do things a little differently these days, because what we do is we'll set our wheel mount surface hub assembly in the computer, lower arm to some degree, at ride height, right? And then we'll just take, and we will have a, like Jack does, a sketch relative to the desired camber curve that I tell him, relative to the caster I tell him, etc. And it will almost auto-generate the upper arm points for us, and then we can manipulate from there. So let's assume you're not really doing that same sort of program. Then you're doing what I'm referring to, which is you're going to start roughing those bits in and just start manually moving it in the computer and seeing what you like and what you don't like, and change the length of the upper arm, the height of the upper arm in the chassis, the width of the upper arm in the chassis, and your inclination angle and your inclination height. So yeah, you can start by doing it that way and just noting what little changes you make and recycling. The best thing when you're doing that is to not make too many changes at once. Like stick to like 1 or 2 parameters, like the height of the upper arm in the chassis and the width of the upper arm in the chassis, and cycle and change as you get it closer to what you want. So once we get to that stage with client work on long travel based setups, we then shift to drawing some of the specific components themselves. And then nowadays what we do is we actually print stuff for full mock-up. And again, I'm going quickly. I'm going to go into depth on all this stuff, but I'm just trying to give you a quick, brief overview of like the process of designing a long travel kit. And then we go to print stuff for mock-up. And show you some of that real quick. It's fucking dry in here. That's not a great example. One either. That's not one. That's not one. There we go. So here is a lower arm for a Morgan Clark MCD1 kit that we are in the process of finalizing. And this is going to be a sheet metal arm. So right now, we just 3D printed it 1-to-1. And we 3D print this so that you can press bearings into it and cycle it with the shocks. This saves us a fuckload of time and headache on these more complex assemblies, so to speak. This is the upright for his setup. And again, it's a 1-to-1 3D printed upright. That's 1.5 inch bearing lower. And so what this allows us to do is give these over to Morgan. He can put this on the truck, cycle it with shocks, get his shocks mocked up in place, make sure everything is kosher, make sure our camber and caster curve is where we want, make sure the shocks clear the upper arm. I don't have a picture of the upper arm, which I don't know where the fuck that is, but it's another 3D printed piece. So we have the whole assembly 3D printed that we can cycle. And that is something we've been doing the last few years for clients. And it makes a world of difference. Like here's one of the brand new Broncos. And this is a machined arm that we printed. And yes, that is a 3D printed spacer on the top of that upright to verify clearance, etc. And so we have 3D printers accurate enough, but these days, once we go through this stage of, like I was saying, is we set everything up to client specifications, we get stuff starting to cycle where we want with the shock package, and then we rough draw in components, we 3D print those chunks, so they look a little rough, like this. This is going to be a sheet metal arm, so like obviously it's going to look a little bit different being in sheet metal, like you'll see the internal ribbing and the some of the overlays, but this is enough to get him to cycle it, etc. And like here's the upright. We didn't put steering on it yet in this specific example because our goal right now is simply to check the overall assembly of travel, camber caster curves, and the shock package. We're trying to stuff a lot in the front of this specific F-150, so it's kind of a pain in the dick, so we want to make sure we're all kosher. So this is just another thing that we've been doing for a little while now that allows our clients to do everything in real life instead of just trusting the computer and sending everything out to laser and machine and fucking praying, you know? So now we can take feedback from cycling the 3D printed components and do some tweaks and then send all the flat plate out for laser. If there's tubes, those go to CNC laser, and then everything else goes to machine. This saves a lot of time and frustration and gets us significantly closer on that first product to being fucking rad, you know? And that makes a world of difference for our clients. Now, when it comes to center mount stuff, it's done a little differently than long travel stuff in the fact that with center mount stuff, we all, you know, for obvious reasons, we map out the client's goals and specifications. Typically speaking, the guys that are a little bit more involved in racing will be more precise with what they want. The guys that are maybe newer or not necessarily accustomed to some of this or newer to building, they are typically not quite sure in some of the specifications that they want. So I kind of have to talk with them and guide them through some aspects and see where they want to be on some sides of the table with a lot of these variations that we'll get to. So the important thing with center mount stuff, when you're drawing that stuff for a client, is you always start with what they're looking for in the primary, and things are going to be, they're most likely going to have a shock package in mind. If they don't, they need to fucking pick one like right away. They need to know some rough understanding of where they want to be on travel. They also need to be understanding of what's realistic. 28, 29 inches of wheel travel in the front of a trophy truck is not realistic. We have clients that call us, I want more travel than everyone else. Okay, it's going to handle like shit. You know? Or it's just not physically possible. I mean, we've had guys ask for 30 inches of wheel travel in the front, and I tell them, like, that's not going to work. And they're like, well, so-and-so has that. And I'm like, no, they don't. They have like 22 and a half, maybe 23 of usable. And they're like, no, it's like 30, 32. No. So anyways, the point being is you have to be realistic with everything. Wheel travel is one of those things you have to be realistic up front with all of the clients, you know, understanding, so that there's no weirdness said and done when he's thinking he should be having 30 inches of travel and he goes to start cycling the shit that you designed for him or that we designed for him or however you want to put that. And it's at 24 and then you get that bad phone call and you're like, well, 30's not fucking going to work, bro. But so first and foremost with everything, always go off specifications and goals. Then, unlike the stuff with the long travel base, on center mount stuff, I always start with inclination and scrub with the client first and foremost. Some clients like more, some clients like less, but that's our starting point because you just let that thing be set from the start and you design inboard from there. So then we're going to take our tire hub package, all that goodness with our inclination and our upright, set that into the computer and work inboard. So we're going to take that. Then we're going to set our, I kind of like to start at ride height, typically speaking with these. Set our caster and then set our camber because both of those are going to have a number associated to them relative to the client specifications. Then you're going to get the lower arm in place. Again, per client specifications, get the steering in place too. Like if you're going to do a rack setup, you want to put that in right away to make sure that you're not going to be hitting anything. The steering swinger setup is very similar, but steering swingers, you can get away. There's not quite as much of a collision typically with swingers as there are with some of the rack stuff relative to the lower arm. But that being said, it's always good to start placing some of those bits while you're placing these other bits. So get the upright in place with your inclination set, your Trackwidth set from the wheelbase. From the wheel mount surface measurement. And start placing your lower arm in your center mount. Start placing your steering rack for clearance or steering box and bits for clearance. Then start mocking in your upper arm. Then you're going to, and again, you're just doing points. Then you're going to get the shocks in place. You're going to start cycling it. You're going to go off of the client specifications for compression. You're going to go off the client specifications for camber curve. Whether or not there's inconsistent or consistent caster, you need to take that into account. And you're going to follow the direction of what your client wants and start laying stuff out. Upper arm, pivots on the chassis, etc., etc. And then you can start drawing and roughing in some of the major bits once you have all the camber caster curves dialed in how you want and your steering dialed in how you want, Ackerman dialed in how you want, toe curve dialed in how you want. Notice how I didn't say bump steer. And so from there, typically it depends. Some clients do not want to do the 3D printed stuff, and I get that. We always try to get them to, because we have the ability to 3D print one-to-one full fucking arms and everything. And let me show that right now. Well, here's one of our big printers. We design and build our own printers. PIY Printers is the company. We are going to be selling these as kits, so other guys that do what we do can have these printers. The print volume on our new generation of printers is 70 inches by 36 inches by 53 inches tall. So all these off-road components you can print on these. And you're going to be able to build these printers. Like I said, we're selling them as kits for well under 20 grand. Like probably like $15,000, $16,000 you can build them for. But it might be 20 grand by the time you see this video thanks to Biden inflation. But that's a whole different series of videos and conversations. But here's a good example. So here's an upper arm we did for a client. And we want to do this before they go to machine. This is an expensive as fuck arm to machine. Well, everything is all relative. It's not expensive for our clients. It would be very expensive for me. Like I can't afford to build these sorts of vehicles. I can afford my UTV. But these are very expensive assemblies. So we want to 3D print the stuff to do check fitment before stuff goes to expensive machine. Same with lower arms, things like that. I don't have a lower arm example. It just dawned on me. I have not really taken pictures of lower arms that we have printed other than like that one from Morgan Clark. But that's a long travel kit, not a center mount. There's just an example of the size of the printer. But you want to print all of it. Maybe not the bulkhead. We haven't really printed bulkheads yet, to be fair, because those can be just kind of built straight from the computer, and rarely are those issues. Rarely. But the arms themselves and uprights, you kind of want to print them. So like here's an all-wheel drive upright we printed to check fitment and all the bee's knees. This is for a Class 1 car, actually, an all-wheel drive Class 1 car. And so it just helps to to make sure the client specifications in real life match what you have put in the computer, and it keeps everyone's expectations and financial expenditure in the green. Because if you fuck something up in machining expensive uprights like this, dude, it's not good, man. Like that's gonna be a bad phone call. Even upper arms like this, it's hard to tell, but this upper arm has a curve into it to match caster and travel with that bearing to be all bitching on the upright. And that, so in other words, it's not a flat upper arm. So there is some expensive machining in this, and we don't want clients to get all fucked up from that. So once we get that and it's all rad, we may make some tweaks after they give us the thumbs up. They might be like, yeah, I love everything at Cycle is great, but I want to change this one part of the arm to X, Y, or Z, and then we'll go from there. So again, it adds a whole nother layer to the step of computer to real life, and that layer that's in there allows us to get the real life components even closer to what the client's vision is and client specifications. And I feel like that's a huge advantage that we didn't have when I started out. This 3D printing stuff is still relatively new. Like I'm saying, we're just now getting the ball rolling on these big printers. And they will be available shortly, real soon here. We have an extrusion system, a dual extrusion system we're proofing right now. Same with a heated chamber system. So like we're right fucking there. But to be able to get these printers in the hands of guys that do what we do and other shops and things like that, to be able to appropriately do the same bullshit. That's the goal. Make things easier all over. But yeah, so there's some quick and rough rundowns of doing these setups appropriately from start to finish. So up until now, we have basically, we're on cool. So I think this is a good stopping point for today. We're through the first 2 pages of the outline, and we are almost to the 3rd page. The next major chunk, and why I want to stop right now, is shock and bump layouts. And this is going to be a decent chunk of conversation. This has got to be hour to an hour and a half of just discussing this stuff. And so this is a really good base to start this mini series of videos with. As you can tell, I tried to go as fast as I can. I've got a lot of passion for this stuff. I fucking love this shit for some reason. I have tried to leave the off-road industry and always come back. And I don't think I'm ever going to leave again. So it's just one of those things. And you have to be in it, and you have to have some of the experiences that I have with the big boy shit, the trophy trucks, the serious Ultra 4 type stuff, the UTVs, all of these things. It's not like you're putting around in a Jeep. This is a whole nother level and avenue to off-road that very few people get to experience. And I feel like once you understand and have the experiences, it's like you get obsessed. Hence why guys like me have a career in this, because people with a lot of fucking discretionary income pay me basically to do this shit day in and day out that I love. And so it's not like I have a job. I get to do this sort of engineering for all these complex and really cool assemblies that, most people are going to more like a normal job. So it's really cool. I absolutely love it. I'm incredibly thankful. We've done great to where like I can do this type of bullshit. I built a fucking studio, I launched DIY Off-Road. I've got my right-hand man, Jack, that works with me too. And he is plugging away. Like right now, he is working on a Bronco project for a client. You know who you are. I spoke with you earlier today. So if you see this video in the next few days, I think you'll know exactly what I'm referring to. But this is just a great start to this conversation of independent front suspension stuff. And to give you some little highlights of where I'm going with it, I've got a great section on shock and bump layouts that do include slapper arms, another personal favorite of mine. Then we've got a whole section on vertical versus horizontal bearings in the arms, and I'll go in more depth in that. Then we've got a section on camber curves. We got a section on caster setup, and a lot that we can talk about that. We got a section on rake, bulkhead rake, so a good chunk on that too. Then from there we move into bumpsteer / toe curve, the zero bumpsteer myth. We can talk about some cool stuff in that, Ackerman. Then I go into steering rack setups, some of what we see and do with quackulations, and where the things are that you want to look for. Steering box setups and quackulations with some of that stuff. Kind of how we like to design some of those bits. And so again, a whole, I mean, these are multiple hour, I mean, these are at least an hour per section. Then from there, we're going to dive into fabrication design style of components. We're going to start with lower arm, and that's a whole page right there of lower arm fabrication style and components. So like ways I like to do things, ways clients of us have had stuff done, other guys that design stuff too. Again, you know, I'm not the end all be all. There's a lot of talent in this industry. There's guys that I look up to who make a lot of cool shit, a lot of great stuff. So by no means am I the end all be all. Then there's upper arm as well. So we're going to focus on some of these specifics. Again, another page and a half just on the upper arm. A lot of cool stuff to talk about. And variations of designs. Lots of cool ways to do things. Then we'll go on to bulkhead construction. So obviously, different ways of doing bulkheads, and different strokes for different folks, all inside of that. Then we're going to move on to some of the steering stuff. So like rack adapters. So like different ways of making rack adapters, machined and fabricated, details. Steering swinger systems, both machined and fabricated, and details on making that stuff, toe links, tie rods, stuff like that. And of course, uprights. Uprights for rear wheel drive setups, and uprights for all-wheel drive setups. Then we're going to go into stuff with some sway bars, etc. And then I'll end on some VPP stuff, which is relatively new. That's Nestor Berardi stuff. But again, we'll get to that. So those are the main sections I'm going to be covering in these videos coming up here. So this is one of this mini-series. That could be 4, 5, or 6 videos. I don't really know at this point. But I'm going to do my best to get you as much information as fast as I can. I know it sounds crazy. It sounds like a lot, but I've already cut this down a decent amount because I felt like some sections I was getting way too technical and dragging stuff out that's like, it's just too much. We're trying to do the best we can to give you a great overview of independent front suspension design from guys in my position and perspective for what would be like long travel setups, both rear-wheel drive and all-wheel drive, and leaning a little bit more towards desert stuff with some hints towards KOH, some hints in the buggy stuff, and some hints towards UTV. So with that said, I appreciate you guys. I appreciate you spending the time. If you guys ever have questions or want to talk shit directly, just send me an email, jason@Tekkconsulting.com. Or write shit in the comments, whatever. Be sure to hit the dislike button because the communists at YouTube do not deserve any of your fucking likes, no matter what the video is. And until next time, gentlemen, thank you and pitter patter.